For any assignment-related queries, call us at +1 678 648 4277. You can mail us at info@statisticshomeworkhelper.com or reach us at https://www.statisticshomeworkhelper.com. Problem 1. Answer each of the following questions in a few sentences. A. Suppose that Y is a random variable, E.G nitrate concentration in a lake. Also, suppose that you have taken 20 nitrate measurements Y1, Y2, Y20 at various times and locations. Explain the difference between E, Y, the expectation of Y, and Mi, the sample mean of Y. B. Define the concept of a random sample and explain why it is useful. C. Why is the sample mean of Y1, Y2, Y20 a good estimate of E, Y? Solution. A. The random variable Y is characterized by its probability density, which describes the likelihood of obtaining an observation in a given range, or interval, of values. The expectation E, Y, is the first moment of this density. It is a property of the density rather than any particular set of data. The sample mean Mi is the arithmetic average of a particular set of data and is derived from the data rather than the density. statisticshomeworkhelper.com. B. A sample is a set of measurements Y1, Y2, yn of some random variable Y with a probability density Fy, Y. The n measured values can be viewed as particular outcomes associated with n related random variables, one for each member of the sample. Generally speaking, these n random variables are described by a multivariate probability distribution. If the sample is random, the Y's are independent and all have the same marginal probability density Fy, Y, as the original variable Y. These properties greatly simplifies the task of deriving the probability distributions of estimates computed from the sample. C. The sample mean is a good estimate of E, Y, because it is unbiased, E, Mi equals E, Y, and consistent, var, Mi, goes to 0 as the sample size approaches infinity. Together, these properties imply that the sample mean converges to the expected value of Y as the sample size increases. Problem 2. Suppose that the soil porosity Y is a random variable that varies over space. Porosity is a fraction defined as the volume of voids, volume not occupied by soil grains, divided by the total volume of the soil sample. Suppose that you wish to estimate the expected value E, Y, of the porosity from 5 observations. statisticshomeworkhelper.com. A. What is a reasonable probability density to assume for Y? Is it better to estimate this density from the 5 samples or to simply postulate its form? B. What would you use as an estimate of E, Y? C. How would you derive the probability distribution, e.g. CDF, of your estimate? What could you do with this distribution? Solution. A. Since porosity is constrained between 0.0 and 1.0, a uniform probability over this, or perhaps a more limited range, is a reasonable choice. A CDF or PDF estimated from a sample size as small as 5 is unlikely to be very informative. An assumed uniform density is probably a better choice. B. The sample mean is a good choice, for the reasons given in the solution to problem 1c. C. Since the sample is quite small, a large sample assumption is not really justified. It is probably better to carry out a stochastic simulation by generating many, thousands, of 5 measurement samples from a uniform random number generator with specified lower and upper bounds. The sample CDF obtained from the simulation could be used to test hypotheses about the properties of Y or, if the bounds used in the generator are varied, to construct confidence intervals for these properties. statisticshomeworkhelper.com. Problem 3. Consider the following 10 samples of suspended sediment concentration, in mg/L, taken at various distances up an estuary, rounded off to facilitate calculation. 6, 10, 11, 10, 14, 10, 13, 4, 7, 6a. Derive a two-sided 90% confidence interval, 10% significance level, for the expected value of sediment concentration, using a large sample assumption. Do you think this assumption is justified? B. Formulate a large sample two-sided test to accept or reject the hypothesis that the mean concentration is equal to 12 mg per liter. What is the p-value obtained with the data set given above? Solution: A. The appropriate estimator for the mean concentration is the sample mean μ, which has the value psi equals 9.1 for this particular sample. StatisticsHomeworkHelper.com. If we adopt a large sample approximation, we assume that the sample mean is normally distributed with mean E, μ equals E, y, the unknown true mean, and standard deviation SD, μ equals SY/N1/2 equals 3.25/10, 1/2 equals 1. The critical points for a two-sided 90% confidence interval are given by MYL 0.9 equals psi SD, μ 1.64 equals 9.1, 1.64 equals 7.5. Mu 0.9 equals psi plus SD, μ 1.64 equals 9.1 plus 1.64 equals 10.7, so we infer from the data that E, y, lies in the interval between 7.5 and 10.7. In fact, the samples were generated from a log normal distribution with a mean of 8.33. The large sample assumption is reasonable, even for a sample of 10, for a significance level of 10%, but becomes less accurate as this level decreases. B. The hypothesis is H0, E, y equals 12. The hypothesis test is based on the same estimate and probability density as the confidence interval calculation. In the two-sided case, the decision rule is accept H0 if MYL, alpha less than or equal to μ less than or equal to mu, alpha reject H0, otherwise statisticshomeworkhelper.com. Where MYL, alpha and mu, alpha are the critical values for a significance level of alpha. For this problem, we do not need to carry out the test or evaluate the critical values. Instead, we look for the p-value. The p-value is the value of alpha that we would given my critical value equal to psi. This can be found by setting the appropriate critical value, MYL, p if psi e, y, and mu, p if psi e, y equal to psi. In this example, psi e, y, so we use MYL, p equals psi. This is equivalent to a standardized, unit normal, critical value of. The probability that a unit normal variable is less than minus 2.9 is, from the tables in the text, 0.002. For a two-sided test, the p-value is twice this probability, so p equals 0.004. This is a very low value, indicating that μ equals psi equals 9.1 is quite unlikely if E, y equals 12. So we would reject the null hypothesis, unless we wanted to use a significance level less than 0.004, an unusually low value. Problem 4. Consider the following four values of the independent variable, daily precipitation, and the dependent variable, streamflow the same day, in a small watershed. StatisticsHomeworkHelper.com. Rainfall, mm 1015 820 runoff, mm 6 8.54 15 derive a regression, least squares, model which has an intercept of 0, a 1 equals 0, and a slope to be determined from the data. Use this model to predict the runoff that would occur when the precipitation is 25. Sketch the data on an XY plot. Include a plot of the regression line over the range x equals 0 to x equals 25. Solution: the least squares estimate minimizes the sum squared error. StatisticsHomeworkHelper.com. With respect to a 2. The minimizing value of a 2 may be found by applying the general least squares estimation equations or by setting the derivative of SSE, taken with respect to a 2, equal to 0 and solving for a 2. This gives a2 equals 0.658. Substituting a 1 equals 0